Hi everyone! In this video, we will analyze a hypothesis test and make conclusions. A researcher states that the average number of hours spent by learners on homework per week is not 15 hours. You wish to test this claim. A sample provides a z-statistic of 1.45. Assume the significance level is alpha equals 0.05. What is the p-value and the conclusion for this hypothesis test? The first thing we need to find are the hypotheses. We need the null hypothesis and the alternative hypothesis. We were told at the beginning that we are looking at the average number of hours spent. This means that our hypotheses will have a mu for average, and that the researcher states that the number of hours is not 15 hours. When we see is not, that means that it is not equal to, so we know that the alternative is not equal to 15. That makes our null hypothesis equal to 15. We know this because an alternative hypothesis must have either a lesser than, greater than, or a not equal sign, and the null hypothesis needs an equal sign, or it can also be in conjunction with an inequality, so it could have a less than or equal, or a greater than or equal to. Now that we have our hypotheses, let's finish organizing all of the information that was given to us. We were given a z-statistic of 1.45 and an alpha of 0.05. So let's put these here, that alpha is 0.05 and our z-statistic is 1.45. The z-statistic is also considered our test statistic. And lastly, we were asked to find the p-value and make a conclusion. So let's organize this here, that we are looking for a p-value and a conclusion. Now looking back at our hypotheses, the alternative hypothesis says that our average is not equal to 15. There are two ways not to be equal to 15. That's either greater than or less than. So we have a two-tailed test because we have two ways to not equal. We're lucky to have a tool using Desmos that we can organize our type of tailed test, enter in the significance level, and adjust for our z-statistic, and it will calculate our p-value so that we can make our conclusion. So let's open up our tool, and we're going to choose the two-tailed test by clicking the dot and bringing it down to two tails. Then we need to change our significance level to 0.05. So we'll click the purple dot and move it over. And then the last thing we need to do is adjust our z-statistic to 1.45. And sometimes it's a little finicky, so we have to get in there really close. And I can't see the numbers, so I'm going to change the tail of the test a little bit just to move it out of the way. Now I can get it into 1.45 and change it back to the two-tailed test so that we can see all of our numbers. We can see that the p-value is 0.147 and our z-statistic and critical value are below. So we have two ways that we can make our conclusion. First of all, we have the p-value, which we were asked, 0.147. And we can compare this p-value with alpha. 0.147 is our p-value, and it is greater than our alpha, 0.05. So p is greater than alpha, and we know that if p is greater than alpha, we fail to reject the null hypothesis. We can also look at our z-statistic and our critical value, and we can see over here on our graph that the z-statistic falls here outside of our, right here, this critical value, which is the cutoff for the rejection region. As a reminder, as we get close to the middle, this is our fail to reject region. So we have two ways for our conclusion. We could compare the test statistic and critical value. We can also compare the p-value with our alpha. And if the p is greater than alpha, we know that we fail to reject. We can also see that our test statistic or our z-statistic, which is less than our critical value, which we have as 1.96, putting it in the fail to reject region. So we have our two ways of making our conclusion right here, and now we're all done.